So let's look at a second derivative example. So find the second derivative of w with respect to z. So this is written in w's and z's this time. That's okay. The same thing as what we do when we have x's and y's. So let's first find dy dx. But did you notice that this is a product? I have 3z squared times e to the z power. So I will use the product rule. I will use the product rule to find w prime. Okay? So product rule says, well, not says yet. Let me go ahead and write down the pieces first. F is 3z squared, the first term. What is the derivative of that? Ooh, that will be 6z, right? 6z. Using the power rule, 3 times 2 is 6, and I have to go down 1 from 2 to 1, so we got that. Next, the second piece of the function is e to the z. Oh, well, the derivative of that is just e to the z, and that's theorem number 5, the very first theorem that we talked about in this lesson. So let's find w prime. Product rule says to find the derivative, do first times the derivative of the second plus second times the derivative of the first. So let's put them together. My first w prime is f times 3z squared times g prime, which is e to the z power, plus g e to the z power times f prime, which is 6c. I'm going to simplify this by factoring out this e to the z power, okay? I'll bring this out to the front. If I do that, I will get ez times 3z squared plus 6z, okay? I'm now going to have to go on, don't you think so? They wanted the second derivative. We have the first derivative. I guess you can factor out the z, but I don't think I want to do that so much because I see a product again. Do you see that the product is, hold on, e to the z times, that's the first piece of multiplication, right? And the second piece of multiplication is 3z squared plus 6z. So if I factor out z, I'm going to have to, use a product rule and product rule. So I think I'm going to go with this. Orange times gray is what I see. So product rule again. So this time, let me draw some line here. Product rule number 2. The first piece that I see is e to the z power. The derivative of that is just really e to the z power. My z looks like 2. That's why I put this little tick mark in between. All right, next. G, the second piece of multiplication is 3z squared plus 6c. The derivative of that is 6z plus 6. All right, let us find w double prime. W double prime, how cute. W double prime should be fg prime plus gf prime. Gf prime. So if I put them together, starting with f, e to the z times 6c plus 6 plus g. G is 3z squared plus 6c. Oh, I'm out of room. Hold on. I'm out of room. Moving things around. And I need to multiply this by f prime. F prime is e to the z. Okay. So, do you notice that they also have this e to the z as a common factor? So I'm going to factor this out to the front. E to the z comes out to the front. What I have left is 6z plus 6 plus 3z squared plus 6z. And all I need to do is combine these like terms. starting with 3z squared plus 12z plus 6. And I can't help but notice that all these numbers in the parentheses, these are multiples of 3. I really want to factor out those 3, so I will do that. Okay, I will factor out the 3. So, okay, my final answer is 3e to the z times z squared plus 4z plus 2. And really quick, I'm thinking, is this trinomial factorable? Not really. So this is where we will stop. The second derivative problem was a little bit crazy. This is always crazy, don't you think? Because we have to use, we have to find the derivative twice. And in this problem, we had to find the derivative twice, both using power rule. Whoopsie daisies, not power rule. Power rule always comes, but we actually use the product rule twice. So this one took me about 6 minutes. This was a longer problem. But let me just do one more example and then I'll come back and show you the application problems. Find an equation of a tangent line to the graph of g of x equals 5 times e to the negative 3x at x equals 0. Very classic problem, don't you think? We have x is 0. What's y? I don't know. Let's find what y is. Y is g of 5. Not 5, I meant 0. They gave us x is 0. So I better plug in x equals 0 if I want to find the y value. That will be 5 times e to the negative 3 times 0. Oh, look, that's interesting. That is 5 times e to the 0. Anything to the 0 power is 1. So we get 5 times 1, which is simply 5. So we got that the y value is 5. Now, to find the slope, I need to find g prime and plug in 0. So let's find g prime. I'm sorry, I put a m prime here. That was so silly. I should just put m equals. All right. So I say let's find g prime. We want to find g prime so that we can plug in 0 in there. So what was the function? G of x is 5 times e to the negative 3x power. So theorem number 6, I need to multiply this 5 by negative 3. G prime of x is negative 15 e to the negative 3x power. So if I want to find what g of 0 is, so g prime of 0 is negative 15 times e to the negative 3 times 0, which is negative 15 times e to the 0 power, and that is negative 15 times 1. So what we got is that the slope of this tangent line is negative 15. So we got all the numbers that we need to write an equation. These are the 3 numbers that I will use. If I use my point slope form, the equation will be y minus 5 equals negative 15 times x minus 0. I can quickly write this in slope-intercept form by distributing that negative 15. The right-hand side becomes negative 15x. Add 5 to both sides. The final answer is negative 15x plus 5. So great review problem. I put something like this on your first test. Just that one didn't involve an exponential function with base e. So that is enough for this video. The next ones are just homework problems. I got these from your homework number 11, number 12. So if you don't need them, you can just go and work on your homework. But I just wanted to show you at least 2 application homework problems, okay?